So let's get started. Periodic table. I would argue that periodic table is one of the finest things human mind has conceived. Yeah, you can get the recording for these classes. I will share a recording of every class. So in case you can't join someday, that's perfectly fine. I know that many students, there are a couple of students who are having time zone issues because is waqt unka school hota or something. So I am going to record for them as well. So don't worry about it. All right, so let's get started. Periodic table is a collection, an arrangement of your elements. Now, for that, we need to know what exactly is an element. So that's the first term that we will define today. Any idea what an element is? Element is something it's a substance, it's something that's made of only one kind of atoms. Now, what does that mean? Like one kind of atoms. How many kinds of atoms are there? Actually, when we say kind of atom, we are basically trying to tell the proton number, that what is the proton number. And elements all have their unique proton number. So no matter which element you pick, it will have a fixed proton number, and the element will always have atoms with that proton number in there. Okay, so every atom in there will have the same proton number, regardless of which element you pick. It will always have the same proton number for that element. So gallium will always be 31, regardless of what the size of the atom is or where you get it from. It doesn't matter. What matters is that for something to be gallium, it must have 31 as a proton number. Now, that proton number is written right above the element symbol in the periodic table. So let's pick fluorine, for example. So fluorine, if you notice, fluorine is written like this. There's 9 here, there's 19 here. Now, what does this mean? The 9 here means that that is the proton number, and I'm writing it as P positive because protons are positive. So this 9 here means that it has the proton number 9. This 19 here means that it has the relative atomic mass 19. Notice that this is not atomic mass. This is not nucleon number. This is relative atomic mass. Now, what does relative here mean? So whenever you have something with a relative atomic mass, we will need to define that as well. So relative atomic mass is the average mass. So that's the first idea. That's not a number of any one atom. It is the average of all the atoms of that element. So it is average mass of all isotopes. So again, that is another term we need to know. I'll come to that in a bit. Of an element. So that is the one part, that it is the average. So it is average of all the isotopes. And then compared, and this is something that some students have trouble with, compared with 1/12 of carbon 12 isotope or atom. Now, this second line is something that some students find it difficult to understand, that what exactly is 1/12? 1/12 ka kya matlab? So here's the idea. Let's suppose I want to know, so for example, there's a student in my class and they are 16 years old. Okay, so if they say my age is 16 years, then I need to know how long is a year. And then I'll multiply that by 16 to figure out what their age is, right? So if I want to figure out their age in days, I will, for some reason, I will need to know the number of days in a year. So let's take that as 365, and I'll multiply that 365 by 16 to figure out unki age kya hai in days. So whenever you're talking about any measurement you do, anything that you can count, anything that you can measure, you need a unit. Unit for atomic mass is obviously going to have the value 1. Unit ka matlab hi 1 hota hai. But carbon 12, which is our unit, doesn't have the mass 12, has the mass 1. It has the mass 12. So how can your unit be 12? It's hard to figure it out like that. So what we do is we take the mass 12. So let's suppose that is the mass of carbon 12. It's 12, of course. And then if I want to make it 1, what will I need to do? I'll multiply by 1 by 12. And that gives me 1 on the atomic mass scale. So it is 1 atomic mass unit. So that's the idea here, that the unit for measuring atomic mass is 1/12 of carbon 12. So this part, 1/12 of carbon 12 is important because you need to always write that whenever you're going to talk about anything that is relative. This small r means it's relative. You will also see mr as another term. So again, mr is also relative. Now that relative part means that it is being compared with 1/12 of carbon 12. Okay, and relative mass means mass of anything compared with 1/12 of carbon 12. If you're talking about molecule, it is mass of the molecule. If you're talking about atom, it's mass of the atom. If you're talking about isotope, it's mass of the isotope. Now that's the next term that I need to know. What exactly is an isotope? Aren't all atoms the same? So turns out they're not, because isotope is atom of the same element. Now we just talked about what makes an element. So for anything to be part of one element, it must have same proton number. So if anything wants to be fluorine, it must have 9 as its proton number. So just atom में 9 protons honge, that is the one we are going to take as fluorine. But it's not important for that thing to weigh 19. It can weigh 80, it can weigh 20, it can weigh 24, or it can weigh 19. It can be 19, but it doesn't have to be. और उसकी वजह क्या होती है? That they can have different number of neutrons, because in the nucleus, as we know, there is proton and there is neutron. So proton same होना बहुत जरूरी है, but neutrons can vary, and that is why whenever you're talking about isotopes, we say that they're atoms of the same element, which is another way of saying they have same proton number, but they have different nucleon number, or they have different mass, which is another way of saying they have different number of neutrons. I'm writing that as N0 because neutron has a 0 charge. So proton has a positive charge, so I wrote that as P positive. Now, of course, in your exam, you will not write that. You will write the full word proton or full word neutron. So that's what an isotope is. So whenever you take an isotope, you need to take the average. So how do you do that? So how do we do average of that isotope? We take all the isotopes that we have. So I'll take a simple example of chlorine. So chlorine has 17 as a proton number. So any atom of chlorine will have 17 as a proton number. Let me take 2 of them. And one has a mass of 35, the other has a mass of 37. Now this is our example. And chlorine does exist in other isotopes, but these two are the ones that are very stable. We will use that word stable multiple times later on as we study. So chlorine's 35, this one, I'm going to call this chlorine 35. I can write it as that. And this one I can call chlorine 37, which means that it is chlorine. It has 17 protons, but its mass is 37. So this is an isotope of chlorine. It has different mass, but it is the same element. Now, of course, both of them have the same proton number. That's what makes them chlorine. Now, this one, chlorine 35, is present 75% of the time. So you pick a random chlorine atom, there's 75% chance that you will get this one, and 25% chance that you'll get this one. Now, this chance or this percentage is called relative abundance. It's again a ratio, a comparison, because it's telling me that out of 100 atoms of chlorine that you pick, how many will be chlorine 35 and how many will be chlorine 37? And the number is 75 and 35, 75 and 25. Now, this is a ratio. It could be 3:1, and that is also the same because you have, for every 1 atom of chlorine 37, you have 3 of chlorine 35, which is the same thing. Now, if I want to take their relative atomic mass, then what will I have to do? So remember one thing, whenever I'm going to take the average, isko aap is tarah socho that in your CIEs, you're going to have 3 papers. You will have paper 1, you will have paper 2, and you will have paper 4. And har paper ki apni weightage hoti hai. So paper 1, let's suppose that weighs for 40% of your syllabus, and paper 4 for 20%, and paper 2 for 40%. I'm not saying that that's the percentage. I'm just giving an example. Now, if some student gets these marks, so in paper 1 they got 32, in paper 2 they got 60, and in paper 4 they got 47. And these are out of 40, this is out of 75, and this is out of 60. And I want to know what their overall marks or grade is going to be. Now, of course, we can simply add them up. We can be like, okay, 32 plus 47 is 79, 79 plus 60. We do 139, and we go like, okay, 139 out of 175 और ये उनका grade बन गया. But ऐसा नहीं है, because there is a weightage that is involved. Paper 1 is 40%, paper 2 is 40%, and paper 4 is 20%. So अगर हमें इनका marks निकालने हैं, इनके grades निकालने हैं, तो what will we have to do? We will have to multiply their weightage, the score, with the weightage. तो जो उनका score होगा, जैसे 32 out of 40 है, तो इसको 40% से multiply करना पड़ेगा. So that's what we'll have to do. We'll have to multiply 32 out of 40 by 40%. Then we'll do 60 over 75 by 40%, क्योंकि उसकी weightage 40 है. And then we'll do 47 out of 60 by 20%. And that tells us the weighted average, the overall score that these students are going to have. Now this gets 32%, and that student gets 32% as well. And this student gets 15.7%. So now their overall total is going to be, we add them all up and we get, okay, this student has an 80% marks. अगर आप इन तीनों को ऐड करते हैं ना, तो उनके मार्क्स 80% के करीब आते, exactly 80 नहीं आते. But this time the student has a different weightage of each paper, so इस वजह से उनके मार्क्स उस तरह से हुए हैं. Now this student has lost a large number of marks in paper 2, but still they ended up with a decent grade. Just like weightage matters for your exam, weightage matters for the isotopes. So हमारे पास ये जो percentage है ना, we'll take that as the weightage, and this 35 and this 37 will take that as their score. तो हमारे पास chlorine 35 times 75% हो जाएगा, plus 37 times 25% उनका दूसरा score हो जाएगा. And when we add this all up, we end up with 35.5, which is our relative atomic mass for chlorine. So let's take another example, and this time you're going to solve it. So let's suppose neon has 3 isotopes. Neon has proton number 10, and neon has isotope with mass 18. Neon also has proton number 10 and isotope with 20, and neon has another one which is 21 and 10. Okay, now this has a abundance or weightage of 25%. This has an abundance or weightage of 70%, and this one is not given. Now, can we find a way to figure out this X, कि उसकी weightage कितनी है, इसकी abundance कितनी है, and then use what we have learned about weightage and relative atomic mass to figure out the atomic mass of neon. Go on, do it. All right, so the first idea is that because we have percentages, then this X and 70 and 25, they should all add to make 100%. So that means 25 plus 70 plus X should equal 100, which means you have 95 plus X equal to 100. So X is going to be 5%, 100 minus 95. So that means neon 21 is 5%, neon 20 is 70, and neon 18 is 25%. Now, what we'll need to do is we'll take their relative masses and add them all up. So this one, just like Shayan has done here, we're going to multiply 25 with 18. This one we're going to do 70 times 20. And this one we're going to do 5 times 21. And because they're all out of 100, we can divide them all by 100 and add them. So it doesn't matter whether you add first or whether you divide first. Because you're dividing them all by 100, answer आपका same ही आएगा. So 25 times 18 plus 70 times 20 plus 5 times 21. Make sure you have a calculator, a scientific calculator with you, and you get your answer, which is, so I'm getting 19.55, which will round off to 19.6. And that is my relative atomic mass of this. No, it's not 80%. It is 5% because the total should add up to 100%. So I'm getting the relative atomic mass to be 19.6. Now, you might argue कि हमारे पास तो 19.6 वाला कोई atom है ही नहीं और हो भी नहीं सकता, because you can't have 0.6 neutron or 0.6 proton. But that is because this is average. Average can be in points. Actual value किसी atom के mass की points में नहीं हो सकती, but individually that is not possible, but together their average can be in decimals. So if you look in the periodic table, then we have chlorine, which is 35.5, and that is because the relative mass, the average of chlorine, is that. Okay, so now we know what an atom is, we know what an element is, we know that elements have same kind of atoms, and we know that for different atoms they have same protons but different neutron number, but still they make up the same element, and we call them isotopes. We also saw that for those isotopes we take the relative atomic mass, and relative atomic mass का तरीका भी हमने देख लिया. Similarly, for compounds, because yeah, MR does work the same way, but for MR things are even easier, because MR is average of all the isotopes of all the elements that are in there. So we'll take a simple example of, let's say, ethanoic acid. So ethanoic acid, if you look at the formula, then this is CH3COOH. Now this is not an atom. This is not an element. This is basically a compound, because compounds are atoms. When they join together chemically, they make different substances, and one of those is compound. Now, here's the thing. This ethanoic acid, if I want to figure out what its MR is, then I have two ways. Either I take the average of carbon, then these three hydrogens, then this carbon, then these two oxygen, and then one hydrogen, in the same way as I've done here. But that will be very extensive और बहुत ज्यादा काम करना पड़ेगा, और मुझे उसकी जरूरत भी नहीं है, because scientists have carefully calculated the relative atomic masses for me. In the periodic table, I have all those values given to me. So all I need to do is take those values and add them up. So what will I do? I will figure out how many carbons I have. So I have 2 carbons, I have 2 oxygens, and I have 4 hydrogens in total, 3 here and 1 here. So I'll just add the relative mass of each atom, and there you go. MR is there. So 2 times 12 for carbon, 2 times 16 for oxygen. I'm getting all these values from the periodic table. I've sent a copy in the group. So make sure you have a print of that with you in the next class. And I'll just add them all up. So this is 24, this is 32, and this is 4, which makes the total 60. So I don't need to take into account the averages or the relative abundance, because people have already done it for me. So मुझे वो अलहदा से करने की जरूरत नहीं है. Sure, I can and I will end up with the same answer. 60 ही आएगा, लेकिन इतनी मेहनत की हमें इस वक्त जरूरत नहीं. We have half the job done for us. Okay? All right. So I'm going to give you a compound. Try to figure out its relative atomic mass. We have 1 copper, we have 1 sulfur, and we have 4 oxygen. Whenever you make a list like this, it makes it easier to get the right value and reduce the chances of error. So copper is 64, sulfur is 32, and oxygen is 16, so 4 times that. And that brings the total to 64 plus 64 plus 32. That's a total of 160. Now here's the thing. Copper sulfate is white, but it can also be blue, because when it is blue, it has copper sulfate with 5 water in it, and that is when it becomes blue. Now, the reason it has changed this color is because water allows it to form these crystals that are colored. Now, the detail of that we study in A levels, so I won't go into that. But for now, just remember that you have a way to test if water is there. कितना आसान है. You can check if something has water by adding a drop in copper sulfate powder. If it goes from white to blue, that thing has water, and if it stays white, that means it is not water. So that's a simple chemical way to test if water is there or not. Now here's the thing. Whenever you add water to the thing, it becomes heavier. So this water molecule, which we'll call water of crystallization, adds some mass to this thing. And we can do it, and we can actually, we are even tested on it in paper 4, we are tested on it in paper 2, that how much water crystallization is there. So we can easily add the mass up. So we already know what copper sulfate's mass is, 160 plus 5 times water, and water has a mass of 18. How? It has 2 hydrogens and 1 oxygen. I add them up, I get 18. So 160 plus 5 times 18, that is 90 plus 160, that's a total mass of 250. Now, sometimes we are asked, okay, you know the percentage abundance of elements. How about percentage of water in the compound? And that's perfectly fine. We can calculate that because 90, which is the mass of water in there, out of total 250 will be the percentage of water. So percentage of water is 90 over 250 times 100%. And this is called percentage by mass. कि आप किसी भी एलिमेंट का किसी भी कंपाउंड के अंदर दूसरे चीजों को ऐड अप करके you can find their percentage in there. And there you go. This tells me that 90 divided by 250 into 100%, that is 36%. So when I have water of crystallization, the molecule, I'm sharing the screen. Yep. Yeah. So basically, this percentage of water, 36%, mass is added to copper sulfate crystals when you get them. So if they're blue, they are 36% heavier than the white ones. You need to remember the color. You need to remember water crystallization, the definition of that. And secondly, how you can calculate the mass of this. Now, that's the first idea. Now, if I can calculate the mass for water, then why can't I just calculate the mass for any other element? Turns out I actually can. So for example, if you take copper sulfate, and I'm keeping the white one, not the one with water, and I want to figure out, okay, isme copper kitna hai? How much of it is sulfur? How much of it is oxygen? I can easily calculate that because the total MR is 160. I know that. But out of that, how much is copper? So copper is 1 copper out of the total 160. So 1 copper out of copper sulfate times 100%. That is going to be 64 over 160 times 100%. Similarly, if I want to figure out how much sulfur is there, I have 1 sulfur out of the total thing. I'll multiply that by 100%, which is 32 over 160 times 100%. Similarly, I can have oxygen, and I have 4 oxygen here out of the total copper sulfate into 100%. And that gives me 4 times 16 over 160 times 100%. And I can just put all the values in the calculator, and that brings me 40% of copper and 20% of this thing. And obviously that will give me 40% of oxygen. जिसका मतलब क्या है? That if I want to get copper out of copper sulfate, then if I have a kg of copper sulfate, I'll get 400 grams copper in there. And this is called percentage by mass. And that is something that we usually get in the exam, 3-mark question, 4-mark question on what this is. Agar water of crystallization bhi aa jaye, to usually we add 1 mark. So usually this is tested in paper 2 and sometimes with paper 4 for water of crystallization. Now I'm going to give you a compound. Go on, calculate its percentage by mass for the elements that are in there. And this one is a simple one. This is aluminium oxide. And by the way, we use these calculations in industry when we are actually trying to mine aluminium. So go on, figure out how much percent of this is aluminum and how much percent of this is oxygen. Now that we know how to figure out percentage by mass, we can even check out how much of aluminum we can extract if we have, let's say, 2 tons of aluminum oxide. So all we need to do is, Yacha, I know what percentage of aluminum is there in aluminum oxide. So it is 2 aluminum out of the total Al2O3, which is 2 aluminum, 3 oxygen. And then multiply that by 100% to find percentage mass. So this is 2 times 27 over 2 times 27 plus 3 times 16 into 100%. Put it on in a calculator. You should get the modern calculators from, I'm using a Casio one. You don't have to get this same model, but you can get the ones that deal with fractions. Make sure that you do that. So that gives me a total of the total MR. And then when I divide this all in this form, I get 52.9%. So 52.9% of this compound is aluminum. So agar aapko 2 tons of it is available. So 2 tons, remember that 2 tons, how much is that? So 2 tons will be 2 times 52.9%. So if I have 2 tons available, out of that, I can actually get 106, wait a minute. Yeah, sorry, 1.06 tons of aluminum. So it's pretty handy knowing percentage by mass in the compound. Now, what exactly is a ton? So because it's a first class today, we need to fix our units. We need to get our units right. So we will be working with mass, we will be working with volume, we will be working with amount of substance. So there are 3 main things that we'll be working with. So for mass, we have these units. So for mass, we have a unit of grams, but we also very rarely use kg. And in MCQs, we sometimes get tons. Now you need to know how many grams are there in a kg and how many grams are there in a ton. So here's the thing. A gram is 1 gram, of course, but a kg, K means 10 power 3. K means 1000. That means 1000 grams. You can also write it as 10 power 3 grams. And ton is a million grams. Okay, that's what a ton is. A ton is a million grams. So ton is 1 times 10 power 6 grams. I can write it as that, or I can just skip the 1 and give it 10 power 6. Or I can even call it 1 million. So 3 zeros with 3 more zeros. And that is a way for me to know that it is a million grams. So every time you get tons, you need to remember that. Similarly, we will be working with volume. So volume is going to be measured in cm cube. So you need to know cm cube, you need to know dm cube. Now, it's not in your CIEs, but you also use a unit called liters in real life. So remember that 1 cm cube is 1 cm cube and a dm cube is 10 power 3 cm cube. So just like a kg is 1000 grams, a dm cube is 1000 cm cubes. So that's also something you need to remember. Hello, Vamik and Alina. This is O levels. I'm just finishing up. And lastly, we'll be working with moles. So a mole is another unit for measuring out how much of something is there. So mole is a way to count things. We will talk about moles in detail later on, but for now, just remember that mole is a way for us to count how many atoms, how many molecules, how many compounds, how many formula units. I'm using all these words. Don't be scared. We will go through all of that in detail. So mole is obviously 1 mole. That's the basic unit. And it has 6.02 into 10 power 23 of anything that you want to measure in moles. Just like if you want to measure something in grams, you just take that thing and that many grams you have. Just like that, if you have mole of anything, you have 6.02 into 10 power 23 of that. And with that, I'll wrap up today's class.